Hi, I'm Tom. I'm part of Team Tuple and I work as a project manager for a company called Twinkle.
Katie, I'm a transport planner at Jacobs Engineering, and I mostly work in transport modelling. We took on Challenge 1, which focused on tracking social distancing on a construction site using video analysis and machine learning. Our solution was a tool developed in Python which detects pedestrians in a video and maps their location to a rectangle representing a bird's eye view.
COVID has created a lot of different challenges for businesses, particularly operating safely in a socially distanced way. We wanted to use machine learning to help track and improve these measures on construction sites. In order to make sure we were trying to solve a real problem, we created our user story, which you can see at the top of the slide.
Again, our solution uses an adapted social distancing tool written in Python. And this uses machine learning to detect the locations of people in a video. The source code for this is available in our references at the end from GitHub. The locations of people were mapped to a bird's eye view, which allowed us to see when and where people were within the distance threshold. And we were then able to produce a heat map from this showing the hotspots in the image where social distancing was most often violated. The flowchart here shows how the model works. So the script analyzes the video frame by frame. And again, we find the locations of people, plot them on the bird's eye view, and that lets us measure the distance between them.
As it's impossible to measure perspective and distance with only one camera, the tool requires you to select 4 points on the surface of the area, as well as a distance of approximately 2 meters apart in order to match UK guidelines. Once this has been inputted for each camera, we will save these points for future analysis of the same feed. Our script exports a CSV, which we can then use to plot charts and graphs. This is linked to Power BI, so you can simply refresh Power BI and pull in the data automatically and produce an output and dashboard from that.
And looking at the bottom 3 images here, the first shows the location of each of the people in the image mapped onto a bird's eye view. And the purple dots here are people. Whenever there's less than 2 meters between any 2 people, we've plotted the midpoint of the line between them with a blue dot. And in the next image, all of these midpoints are plotted together on the bird's eye view, which we can then finally overlay on the first frame of the video image, this third image that you see here. And that lets us identify the hotspots where people are violating social distancing the most. This here is the PowerBI Dashboard. As Tom mentioned, it's linked straight to the CSV output, so there's no need to import, it could just be refreshed. And it gives the visualization of the data output from the script. So this is where we can get the most insight from it. As you can see in the top right, we've got a clear chart showing the average number of people on screen at a time in this yellow line here. That goes based on an average of the past 5 seconds. And the blue line below that shows the number of social distancing violations in that same time period. In the top left, we've got a chart with some sample data in it for now, showing a longer term histogram of footfall throughout the day. And we also have functionality for multiple sites and multiple cameras per site built into the dashboard.
So where's the value for the business? Well, primarily it's going to be lower transmission risk, leading to reduced absence and improving employee safety. There's potential for more efficient site planning as well, and better equipment storage and shift patterns. We would run the code on the cloud and automatically input this to Power BI. This diagram on the right hand side shows a similar project looking at using camera feeds to track graffiti on trains, and this is a good example of how the workflow would look. This would allow us to not just spot problems, but also test solutions in real time because we'd be doing analysis on live camera feeds.
These are the next steps that we'd like to look at for developing the tool further. We used a pre-trained model, but the detection of people could be improved, especially in the denser places where the current model sometimes detects a pair of people as one person. We expect that this could be improved by training the model with the PenFIDN database, which contains around 100 photos of multiple people from various angles. We'd also like to adapt the script to run on a live video feed, which would essentially export the outputs at regular intervals instead of right at the end.
We'd also want to build it so that it could read data from multiple sites and cameras straight into the Power BI board, and also automatically notify supervisors in real time when violations go over a certain threshold.
References that we used here. The base of the tool is a social distancing tool developed by Akhil Anwar. That's available on GitHub. And he's also provided a really handy guide, which is the second link there. We've got the link to the model that we used, and also a guide on using Azure to set up real-time analysis.
Thank you so much for watching our presentation. We'll now spend a couple of minutes going through the questions from the judges. So the first question was, how might this code be deployed within a real project? So I hope we've kind of given an idea of this. Particularly, this code would be deployed to take in multiple CCTV camera streams and track the violations across multiple sites and cameras. This would allow us to plot when and where a violation is happening and use that information to alter shift patterns, change instructions for employees, and make other changes. Where will the code sit? As mentioned earlier, we would set up the camera streams to be automatically processed on the Azure Cloud platform and then have data input directly to Power BI. How would the user interact with the output? So the user would primarily interact through the Power BI Dashboard, which would automatically create reports and charts of when and where violations are happening.
Next, would the accuracy of the model be affected by people on different levels? It would. The model would probably still detect people okay, but it would give inaccurate readings for the distance because it assumes a flat plane. So a more complex mapping might be able to deal with this, where you import multiple levels at the start. But initially, we think the best solution is to be selective about where you locate the cameras on site. And finally, what impact do we think this would have on a busy site? We think it would have a huge impact. Firstly, in terms of social distancing, supervisors can get a really clear picture of where the hotspots are, and this would allow them to react as needed, maybe to impose a different movement system in the area or to change shift patterns to reduce crowding on site. On top of that, it would also facilitate better scheduling in general. The busiest times of choke points such as toilets or tool sheds could be identified, and this could be managed more efficiently to minimize queuing. Ultimately, we'd expect more efficient project delivery, including cost savings from minimizing absence leave, as well as contributing to the well-being of employees and allowing everyone to feel safer on site.
Once again, thank you for watching our presentation, and I hope you enjoy our solution.